let's go back to the proof of type preservation theorem. So we learned that it suffices to prove this statement, then gamma expression E of type C implies gamma expression E has a type C. So the type is preserved. And the most challenging case is this one, lambda xa dot E value B reduced to value B for x in E. So this is the most challenging case. And the assumption, so from the assumption, this is the assumption, gamma lambda xa dot E value V, this one has a type C. This is the assumption, and then you need to this one, and it is gamma V4X expression E has a type C. This is what you needed to show. And this is the most challenging case in the proof of this type preservation statement. And you can expand this typing judgment to rebuild the partial derivation tree, which is gamma lambda expression E has a type A arrow C, and B has a type A. And you can further expand with this judgment. X has a type A and expression E has a type C. So to summarize, you have this assumption, and this is what you needed to show. And it turns out that a direct proof attempt fails. You will have to apply rule induction one more time. So to simplify the presentation, let's prove this step as a separate lemma. And the assumption allows us to use these two judgments, this one and this one. And this is the conclusion you needed to draw. So let's rewrite the problem this way. Let's generalize, and it is called substitution lemma. Substitution lemma. So let's generalize it. You have something like this. So let's write it. If expression E has a type A. So notice that we are generalizing. Here it is just the value B, but here we use general form of expression E. And then you have this one. Okay, so and gamma xa with expression E prime has a type C, then this is the conclusion. Under the same typing context, the gamma, you substitute expression E for x in expression E prime, and that leaves the same type. So we have generalized the statement into this statement, and this is what we needed to show, and it is usually called the substitution lemma. Let's try to prove this substitution lemma. Remember that this is the most challenging case in the proof of type preservation theorem, and if we can complete the proof of this case, then perhaps all the remaining cases are going to be fine. So let me just show you this case. And the whole proof reduced to the proof of this substitution lemma. So that's the remaining problem. Now, again, we are confronted with the familiar form. If judgment J and J prime, then another judgment J double prime holds. So the question is, shall we apply rule induction to this judgment or to this judgment? And this time, it turns out that you have to think hard, because a wrong choice will lead you to nowhere. So shall we apply rule induction to this judgment or this judgment? And if you think about the meaning of this substitution expression, it means that you analyze every part of the expression E prime to locate the variable x, and then substitute expression E for this variable x. So therefore, you will analyze the structure of expression E prime, but you will never analyze the structure of expression E. In fact, you will just simply substitute E, so you have no idea what this expression E. That's fine, because it doesn't matter what kind of expression E is. We will simply substitute it for variable x. So that's the basic observation, which means that you will have to analyze the structure of expression E prime, or you will have to analyze the structure of the typing derivation for this judgment. So you will analyze this one, which means that you will apply rule induction to this judgment. So let's rephrase this statement. If gamma this type binding expression E prime has a type C, then this assumption implies this judgment for x E prime C. And we will apply rule induction to this judgment. So how do we prove? Prove by rule induction on this judgment. So let me show you three cases. The first case is this expression E prime is variable. So in other words, the last inference rule in the derivation of this typing judgment is variable. And moreover, so this is a var rule. Moreover, so this is a var rule. So E prime is going to be variable. And it turns out that, and we make an assumption that E prime is actually just equal to variable x. So E prime is variable x. That is, we happen to have here, we happen to have the same variable x. Then these two variables are equal, so therefore this type C must be equal to type A. So we have C is equal to type A. So this is the first case. And in this case, we did assumption this one. So the assumption is the gamma expression E has a type A, and this is what we needed to show, which is gamma, this one, E for x, E prime has a type C. And let's see what is going on. E prime is variable x, so this is basically E for x, variable x, which is expression E. So we needed to show expression E has type C. But we have this assumption. Expression E has a type A, but A is equal to C. So the assumption directly implies the goal judgment. So the first case is gone. Now let's consider the second case. The second case also deals with this var rule. So the last inference rule here is var rule. But this time, so expression E prime is a variable, but unlike the first case, it is different from variable x. So again, the assumption is this one. So this is the assumption. So let me write the assumption. This is assumption. And this is what you needed to show. So what you needed to show is E for X, E prime, C. This is what you needed to show in the end. But this time, E prime is variable Y. So let me write the variable Y here. And here also we have a variable Y. Then because variable X and this variable Y are different, you can rewrite it as just Y. This substitution has no effect. So you needed to show that Y has a type C. This is what you needed to show. Then how can you deduce Y is a type C? We go back to this one. In this application of the rule var, we know that Y has type C. But we also have this assumption, Y is not equal to X. So that means that this type binding must be found somewhere in gamma, not in this type binding, because X is different from Y. So in other words, we never use this type binding when we deduce this judgment. So therefore, we have Y colon C, this type binding is found somewhere in typing context gamma. So that's what's guaranteed by this typing rule var. Now, this is immediately provable because we have this one. Y colon C is found in gamma, so we can deduce this one. So the second case is also gone. Now let's consider the most challenging case. The most challenging case is, so let me copy of this statement. So the statement is if gamma xa E prime has a type C, then gamma E colon A implies gamma E for X E prime has a type C. So this is what we need to prove. And the most challenging case is the last inference rule in the derivation of this judgment is arrow introduction rule. So that is, we have a gamma X colon A, and this time we have E prime C, but we apply arrow introduction rule. So that means that expression E prime is something like lambda Y C1 colon E double prime. That E double prime, this is type C. So this expression E prime must have this form. Then the premise goes gamma X colon A, we make this new type binding Y has a type C1, then the body expression E double prime is going to have type C2, where C is equal to C1 arrow C2. So this is the most challenging case. Now, what do we assume? We assume gamma expression E has type A. So this is the assumption. And in the end, you have to show this one. Gamma expression E for X E prime has type C. This is what you needed to show in the end. Then how do we bridge the gap between this initial assumption and the final goal? Let's see. So from From here, we know that the expression E prime must be this lambda abstraction. So that is actually E prime is equal to lambda y C1 comma C1 E double prime. So let me make a copy it over here. So we have gamma E for x lambda y C1 E double prime. It has a type C or C1 arrow C2. This is what needed to show. I just expanded the expression E prime into this lambda abstraction with this equality. So let me write it, C1 arrow C2. And here we make an assumption that this variable y is fresh. So this variable y is a completely fresh variable that is not found anywhere in this typing context. This is a safe assumption because we know that if there arises name clash, we can always rename this bounded variable into fresh bounded variable by alpha conversion. So we can safely assume that y is a completely fresh variable. That means that you can move this substitution into this body. So let me further rewrite. So let me move it into this body. So lambda y C1 E4x E double prime. This is supposed to have type C1 arrow C2. So this is what you need to show. Then the only way to prove this judgment is by applying the same bar introduction rule. So it suffices to show gamma lambda y dot C1 E4x expression E double prime has a type C2. So it suffices to show this judgment is provable. And how do we prove this one? At some point, you have applied induction hypothesis. So let's apply induction hypothesis. So we have this application of error introduction rule. So this is the premise. Then we'd like to apply rule induction hypothesis to this judgment. But there's a problem here. We have an expression E of type A. Okay, so we are ready to substitute. So we are ready to substitute expression E for variable x. But the problem is the typing contexts are different. Here, the typing context, excluding this type binding, the typing context is gamma y colon C1. But here, the typing context is just the gamma. So the typing contexts are different. So it seems like we are not able to obtain induction hypothesis. So the workaround is we'd like to slightly weaken this judgment, and it's called for weakening. So the idea is that you add an extra type binding. This time it is y colon C1 to deduce the same type judgment. So the story is from this typing judgment, you add this extra type binding. And this is safe because you already have the proof that expression E has a type A. So you can reconstruct the whole derivation tree here where you simply ignore this type binding. You never use this type binding. So this is also safe. You can actually find the formal proof of this weakening property in the course notes. So now you have this judgment and this judgment. And now we are ready to apply rule induction. It's a bit harder to identify the typing context relevant to induction hypothesis, but actually it's very simple. You have some typing judgment, you have the same typing judgment, you have an extra type binding, and you have an expression of the same type. So you apply, so you apply rule induction, you apply induction hypothesis to this judgment together with this judgment. Then what happens? Gamma y colon c1, and you substitute expression e for variable x. So substitute expression e for variable x in expression e double prime, which is precisely what we wanted to show. So this is by induction hypothesis on the premise. So this is how you complete this case. So this is the most challenging case, and you can try the remaining cases yourself, and you will find that these remaining cases are no more challenging than this this case.